Here, with respect to the three-phase circuit, you concentrate on advantages of three-phase power supply over the single phase. Then how we are going to generate the three-phase power? In morning class, I have discussed. Okay, all the three phases are to be placed at an angle of 120 degree. Then whenever the conductor is get cut by the magnetic flux, which will causes the induced EMF. Okay, it means that the relative motion between the magnetic flux and the conductor will causes the induced EMF. And the derivation for the voltage and current. Okay, whatever the relation which is to be required. That is the three-phase, the circuit or the elements which are containing the 6 terminal. But those three-phase 6 terminals are get connected in the fashion of star and delta. Okay, means those are the interconnected system of the three-phase elements. Okay, that might be with respect to the star, that might be with respect to the delta. Okay, that is the derivation with respect to that of line quantities and the phase quantities. That might be with respect to the voltage, that might be with respect to the current. In case of star connected system, line voltage is equal to √3 times of phase voltage. But with respect to the current, line current is equal to phase current. In case of the delta connected system, line current is equal to √3 times of phase current. But the line voltage is equal to phase voltage. But with respect to the three-phase power, P is equal to, if it is phase quantity, 3 times that of the phase voltage, then phase current and cos pi, that you remember. Okay, if it is a line quantity, what it is? It is √3 times of VL, then V phase, not VL, IL, then cos pi. Okay, this is with respect to the line parameter. Okay, these two equations you have to remember with respect to the power determination. Then the power measurement in case of three-phase circuit, efficient method is the 2 wattmeter method. Okay, that will be used for the balanced circuit as well as the unbalanced circuit. Then problem with respect to that is line voltage, phase voltage, line current, phase current with respect to the star. Then similar to that of with respect to the delta. Okay, they will give the value of resistance, the value of the reactance. Corresponds that they can ask you make the evaluation of total current, power factor, then amount of power. Okay, these are the problems might be get repeating in the examination. Then the 2 wattmeter method, the total power evaluation, power factor evaluation, then total current which is to be carried by the three-phase system. Okay, that type of problem will also be get repeated in the examination. The whatever the question I have discussed, once you can go through that, if you are getting any doubt in upcoming classes, you can discuss it. Anybody is having any doubt for with respect to this three-phase circuit? All of you listening me, raise your hand. Total 46 members are there, only 26. Okay, drop your hands. Okay, this three-phase circuit is easy compared to that of the single phase. Okay, so that you can concentrate on this one properly for your internal point of view. Then next with respect to the third module. Okay, the third module is containing 3 concepts. Okay, one with respect to the generator, that is the DC generator, another with respect to the DC motor, then third with respect to the single phase transformer. Okay, with respect to the generator, which is converting mechanical energy into electrical energy, but whose output is DC, then it is called as DC generator, which works on the principle of what? Dynamically induced EMF principle. That is relative motion between the magnetic flux and the conductor will cause the induced EMF. Then construction point of view and their function. Okay, that DC generator or the motor, the construction will be remain same, which is having yoke, main pole, pole core, pole shoe, field winding, shaft, armature, armature core, armature slots, commutator, and the carbon brushes. The function of all these parts you need to remember. Then with respect to that diagram. Okay, this will also be important for the examination point of view, 10 marks. Okay, in internal, we might be asking that is for 8 marks. Okay, that is working principle and its construction. These two will also be important. One question will be fixed. Then EMF equation of DC generator. Can anybody can tell what the EMF equation of DC generator? EG equal to
pi ZNP divided by 60.
that is pi ZNP upon 60A. Pi is what?
Flux.
Flux per pole. Then Z is number of armature conductor. N is speed. P is number of pole. A is number of parallel paths. Okay, A equal to 2 when? Anybody? A equal to 2 in which type of winding?
Wave.
There will be two types of winding.
Wound.
Right? Which?
Wound.
Not.
Wave
Two
winding.
condition A equal to 2, A equal to P. A equal to 2, wave winding are
A
A
equals
equal
to
to 2 in case of wave winding, A equal to P in case of lap winding. Okay, that you remember. Okay, this is the what? EMF equation of the DC generator. Okay, this derivation you can practice, which can be asked for 4 marks. Okay, external they might be asking for 5 marks. Okay, then with respect to the types of generator, there will be a separately excited and the self-excited. Separately excited means the external power supply is given to the field winding. That is the separately excited. Self-excited means the whatever the amount of voltage it is generated by the generator will be given as an input for your field winding. That is called as the self-excited. With respect to the self-excited, again there will be a series, shunt and compound. If the field winding is in series with armature, then it is called as series. If the field winding is in parallel with respect to the armature, it is called as shunt. If there be a combination of series and shunt, then it is called as compound. Again in compound, two types. Which are those? Anybody?
Short and long.
That is short shunt and the long shunt. Okay, the series field winding and the armature connected in parallel with respect to that of shunt field, it is the long shunt. If the shunt field and the armature connected in parallel, which is the combination is connected in series with series field winding, then it is called as short shunt. In again short shunt and long shunt, again two types based on adding of the fluxes. Which are those?
Commutative and differential.
That is cumulative and differential type of compound generator. But most commonly, the differential is also be using, then cumulative will also be using. But the differential type will be used in welding application. Okay, then what is the equation for EG? EG equal to V plus IA into RA. Okay, this is with respect to the what? The generated voltage. Then problems will be on based on EMF equation to find the speed and to find the power. But whatever the voltage they can evaluate now. Okay, with respect to the generated voltage, if evaluated for lap, they will ask speed for wave for the same amount of voltage. This type of problem will also be most commonly repeated. Okay, that is the what? The speed relation with respect to that of EMF and the lap winding and the wave winding. Okay, this is related to the what? The DC generator. Then what is motor? Can anyone answer? What is motor? I don't want DC motor. Listening or not? What is a motor? Nobody is answering.
Device which converts electrical into mechanical energy.
That is not the device, ma. It is an electrical machine which will convert electrical energy into mechanical energy. That is called as motor. But if the input is the DC power supply, then it is called as a DC motor. Okay, working principle of the motor. Whenever a current carrying conductor is placed in magnetic field, which will experience a force. That is the what? The working principle of DC motor. What is back EMF? The EMF which is induced in the armature conductor, which will oppose to that of applied voltage. That itself is called as back EMF. What is its significance? What it actually does? Which will regulate the speed. Remember it. Back EMF will regulate the speed. Proportional to the change in load, corresponds to that change in load, speed varies. If the speed varies, back EMF is varied. Proportional to that back EMF, the whatever the speed which is to be achieved by the motor will be get controlled. That is the what? The control of the speed of the DC motor. Okay, that is what? Which will regulate the speed of the DC motor itself. Then torque equation. What is torque? What is torque? Anybody?
Turning effect of force.
That is also be correct. But the turning or twisting force, it itself is called as torque. Then armature torque TA equal to 0.159 pi into Z into IA into P by A. What is P here? What is P? All of listening, Meena? What is P? What is A? Nobody is responding. Because your expectation is that you need to present in class, then you have to update your attendance. P is number of pole, A is number of parallel paths. Types of motors are also be there, separately excited and self-excited. With respect to the self-excited, series, shunt, compound. Okay, then characteristics of the DC motor with respect to the series, with respect to the shunt. You can go through the notes. Then the series motor cannot be run on no load. Why? Which will run at very dangerous speed. Applications of DC motor also you can go through the notes. Then the problems are based on back EMF, speed and the torque. Then amount of power developed by the DC motor. Okay, all these are the concept with respect to that of DC motor. Then with respect to the transformer, what is transformer? Anybody? What is transformer? No one listening. 46 members are there.
Static
Okay, it is a
electrical.
static machine which will transfer the electrical energy from one circuit to another circuit. Necessity of transformer in order to increase the voltage or in order to control the current magnitude. Working principle is mutual induction. Based on construction, there will be a cell type and there will be a core type. These are the two types of transformer. Then with respect to the construction point of view, there will be a magnetic core and the winding. Winding is nothing but there will be a primary, there will be a secondary. Primary winding is connected to the supply, secondary winding is connected to the load.
బాగున్నానండి జోసఫా ఏదో చెప్పాడని నువ్వు ఎందుకు టెన్షన్ పడతావు?
Waste fellows, why you joined? You get out from my class if you are creating problem. Don't have common sense also to mute by yourself. Then EMF equation of the transformer, that is E1 is equal to 4.44 F into pi m into N1. E2 equal to 4.44 F into pi m into N2. N1 is number of turns in primary, N2 is number of turns in secondary. Then K is the transformation ratio, that is V2 by V1, N2 by N1, E2 by E1, I1 by I2. Losses in transformer, there will be a core loss and the iron loss. Okay, the core loss and iron loss are same. These are constant losses. In case of the core loss and iron losses, there will be hysteresis loss and the eddy current loss. Then with respect to the variable loss, itself is called as copper loss. That is the I square R loss. That is with respect to the winding. Then condition for maximum efficiency, that is whenever the constant loss is equal to variable loss, then we can achieve the maximum efficiency. Okay, this derivation compulsory we can practice. This is important for the examination point of view. Then the problems are based on EMF equation and efficiency of the transformer. Okay, all these things with respect to that of the transformer. Okay, then with respect to the